Real quick introduction, my name is Edward Thompson. I'm a senior software engineer at Microsoft. I work on the Visual Studio version control team. So I do the underlying version control core functionality for both Visual Studio and Visual Studio Online and Team Foundation Server. I write about version control. If this is something you're really passionate about, then follow my blog, follow my Twitter. If not, that's cool. I understand. Like I said, version control is something that you kind of want out of sight, out of mind for the most part. Again, I work on Visual Studio and Visual Studio Online. Visual Studio Online is our cloud-hosted application lifecycle management platform. And that's a lot of words, and I was almost going to drop this slide talking about what application lifecycle management means. So when we say, at Microsoft at least, application lifecycle management, what we mean is a single server that has all of the artifacts for your development process. So version control, bug tracking, continuous integration, build and test, deployment, test automation, those sorts of things. And by putting all these things together, you can get some really cool abilities to, say, report up on defects and stuff like that. The reason I almost omitted the slide was, 10 years ago, this was kind of crazy to try to bundle all these things together. But now, I think it's kind of understood to be a best practice that you're using version control, that you're using bug tracking, that you're planning, your sprints in a tool. Meanwhile, I was at the Visual Studio Online booth earlier this week on the expo floor, and I recognize many of you, so hello again. And somebody came up to me and he was like, well, there's only two of us. Do we really need to use version control? And I swear my jaw almost hit the floor. So we talked about, tracking changes and how you might want to, I don't know, be able to roll back if you made an error and understand why you made the changes that you made. And then I was out to dinner with one of my friends. Just got a new job here in Chicago. And he was telling me about the quality at his new job. That's the best, most polite way I can put it is just, we were talking about the quality. And he's been there 2 weeks. And in those 2 weeks, 4 times he's pulled the latest version from his version control server, tried to do a build, and the build didn't succeed. Somebody had checked in without even seeing if it built. And another couple times when it did build, the program didn't even start. So I'm bringing this slide back because I think it's really important to understand how your changes are going on in your organization, that you're tying your version control to user stories or to bugs so that you understand the changes that you're making in the software and where they're coming from. And then to fire off a build and then run unit tests when you do a check-in so that you know that the quality that you're putting into your products is high. So that's what Team Foundation Server is. That's what Visual Studio Online is. And again, 10 years ago, we launched Team Foundation Server. And we sort of built it for ourselves at Microsoft. Team Foundation Server was built to handle the Visual Studio code base. It was meant to handle the Windows code base, which are these gigantic code bases, multiple gigabytes. And when we did that, one of the things we realized was that a version control system that scans your hard drive looking for changes just doesn't work at something that large. It's going to spend all its time crawling your hard drive, looking to see if you've changed anything over and over and over again. And so it's far more efficient if you use, and I'm going to use some version control terminology. I'm pulling it from this book. So this is Eric Sink again, the guy with the quote about version control and sex, which is the only time those two things will be mentioned in the same sentence again. This is his book, Version Control by Example. So he talks about a checkout, edit, check-in model for version control. And that's what we built Team Foundation Server to be. Because if you explicitly check out a file and then make changes, your version control system doesn't need to look on your hard drive to see what you've done. Okay, so that's a lot more efficient if you're dealing with something that's just an enormous code base. It turns out, though, that some people didn't like that. The problem is that you have to be connected to your version control server all the time if this is happening. And if you're a tiny little team of 2 people or 3 people, and you're working on a small, just, I don't know, web forms app, you spend all your time, talking to your version control system, and it's in your way, and you start to hate it. And some people really did start to hate Team Foundation Server. This is just random stuff I pulled off the internet. The last quote is particularly frustrating to me because he was a Microsoft employee when he wrote that. And some people had even taken to calling this Team Frustration Server. So we knew we kind of had a problem. We knew we had a system that worked great for us and worked great for people who had just enormous code bases, but we also realized that most people don't have enormous code bases. Most people have very small code bases, and we built a tool that was in their way all the time. It wasn't in our way. It was great for us, but it was in everybody else's. And so what we started to think about was, can the version control server do less? Can we not talk to it as often? And one of the new models in version control systems is a distributed version control system. And what that means is that everybody has a copy of the repository. You're no longer dependent on a central server to arbitrate your work. Now, you can have a central server. You still want a source of the truth. You still want to know what code is good, what code you want to ship. You don't want to start going back to the bad old days where you're cutting builds on a developer's machine and everybody's got a different idea of what might be current. But in a distributed version control system, you don't need a central server. It was built so that everybody has a full copy of the repository. And everybody thinks I'm lying when I say that somehow everybody has all of the files that make up the repository, but not the history. I mean everything. History, branches, everything is in the repository that you get in a distributed version control system. So that's kind of a modern take on version control. Whereas the old TFVC model is called centralized version control, this is a new concept called distributed version control. And we use a distributed version control system called Git in Team Foundation Server and Visual Studio Online. And that's, of course, what we're going to talk about today. Now, Git is great. Like I said, this was really pushed by smaller dev shops. And that's where it really shines. Because again, you've got all this data coming down to have a full copy of the repository. It's not going to work well for the Visual Studio code base or for the Windows code base or something just truly massive. It works really well for modular code bases because you've got the entirety of all of the files, all of the history. It works best for small projects that can be independent in their own repository. It works really well for highly distributed teams like the name suggests. I work on a team within the version control team that has people. I'm in Boston. I got a bunch of coworkers in Raleigh, several in Redmond. And distributed version control really helps us because I don't have to wait to talk to a server that's half a country away or more. I can just check right into my local repository. Okay? And so, like I said, we've adopted Git as our distributed version control system. Git is a wildly popular DVCS, and it's a great tool. The best part about it is the support. Microsoft supports Git. Many other vendors support Git, so you can use all of our tools together. We like to say we love Git. I've actually got stickers that say Visual Studio loves Git, so hit me up afterwards if you want a sticker of this. Okay, so I've talked a lot about how different Git is, how different a distributed version control system is, and how you have all of these sort of local changes and how maybe it doesn't work for everybody. Let's take a quick look at just what it does look like to get an idea of how you might use Git. So right here I've got Visual Studio Online. And again, Visual Studio Online is is the cloud-hosted version of TFS. This is our application lifecycle management platform. If you're using TFS now with TFS version control, I think this is going to look really familiar. I'm going to go up here and click on the Code tab. And now I'm browsing my repository. This is a Git repository. Again, if you're using TFS VC, this is going to look really familiar to you. And that's one of the things we tried to do when building this new distributed version control support into Visual Studio and Visual Studio Online, is to make it look really comparable to what you're used to. So we try to bring you the power of Git, but with the familiarity that you've come to expect. And so I'm just looking right at my repository. I'm looking at the list of files that are in it. This is just a simple C# application. Here in the middle, I've got some information about when the file was last changed, and who changed it last. Obviously, I can drill down a little bit deeper, but that's just an at-a-glance sort of summary. If I navigate in and let's just find a C# file, click on it, I can get a view of the contents of the file. And this is the Monaco editor. It's the same thing that you'll see again with TFS VC, with some of the Office 365 online editing, some of the editing that's in the new Visual Studio Code. These all kind of share a common viewing and editing framework. So this is a really powerful viewer in the web for Git repositories. If I click up here on history, I actually can see the history, the changes that have been made to this file throughout time. And I can even click compare and get a nice side-by-side diff of the contents that went into the last change. Okay? So again, this should look really familiar to you if you're using TFVC. The one thing that's probably not going to look too familiar, though, is up here in the upper right, I've got this button that says clone. That's kind of the entry point to getting started with a Git repository, is to clone it. Because again, everybody's got a full copy of the repository. When I want to bring that down to my machine, I'm getting a duplication of that repository. I'm getting a clone of that repository. And so that's the terminology there, is to clone it. Okay? So I'm going to click that clone button, and I'm going to get a URL that I can copy and paste into any Git repository management system, into any Git UI. It doesn't have to be Visual Studio. It could be the Git command line client. It could be any other UI client that you might have. Okay? And I'm going to do that. I'm going to come over here into Visual Studio, into the Team Explorer menu. This is the same entry point that you use if you're using TFS VC. And I'm going to click clone and enter that URL that the website gave me. Okay? And I can put it, anywhere on my file system. But what I'm not doing is I'm not setting up working folder mappings. In TFS and TFVC, you have the ability to make really complex working folder mappings to kind of try to, I can map part of the repository over here on my local disk, part of the repository over here, and I can make this custom setup that reflects exactly what I want out of my working folder mappings. You don't get that opportunity in Git. Because Git repositories are small and self-contained, you put them in a single place on disk. And that actually has some really nice advantages that we'll see in a minute. But I'm going to click clone. It's going to download it very quick. Again, Visual Studio Online, it's hosted in Azure, very speedy. And once I do that, I can just double-click on the repository, and that's going to open up the repo in Team Explorer. I've got these buttons look a little bit different than what you might see in TFS VC and TFVC, but fundamentally the same entry points. And one of the things you see down in the middle of the screen is the solution that I downloaded, the solution that was in that repository. So once I'm done cloning it, I can just double-click on that SLN file and open it up. It's going to take just a second. And if I pop over to Solution Explorer, I can start navigating through my project. Okay? Cool. So once I've got my project open, I can just start typing, start editing. I don't have to do anything explicit to check out. I can make some changes. And when I do, you'll notice that this little glyph next to the file name in Team Explorer turns into a red check mark. This is just to indicate that I've made some changes to that file, so when I'm looking in Solution Explorer, I can get an at-a-glance idea of what I've been changing. If I go over to the Team Explorer Changes page, you'll note that it also shows up there. Sorry, I got in the way. You'll notice that that file also shows up there in Team Explorer. These are the included changes that I'm about to check in if I were to click Commit. Okay? And I don't just get this integration into Team Explorer, I also get the integration into the text editor. I can come down here to the source control menu. I can look at the history of the file. I can undo the changes that I've made. I can compare with unmodified. And again, you get that nice side-by-side diff that you've come to expect from TFVC. And this compare we just did was super fast. I didn't have to go to the server and fetch everything. It's all on my local hard drive. Okay? So when I've made some changes, when I'm happy with these changes, I can go ahead in the Changes page. It prompts me to enter a commit message. I'll do that. Again, part of the power of TFVC, of Team Foundation Server and Visual Studio Online, is the integration between version control and work item tracking and build and test integration. And so from here in Team Explorer, I can add a related work item. It's this tab right here. I happen to know that I'm fixing bug number 72. Obviously, you can pull up queries so that if you wanted to know what work items you had assigned to you right now, what work items were assigned to the team, you could drill down into a work item query. I know I'm using 72. I'm just going to hit Add, and you can see that now that pops up there as one of the work items that's going to get associated with this commit when it lands on the server. Okay. At the moment, I'm going to click Commit, and it tells me that it was created locally. And that's true. If I go over to the server, again, I'm just working in a local workspace. If I click on the History button, this change, the most recent change, was from 3 hours ago. So it landed in my local repository, but it hasn't made it to the server yet. If I go back to Visual Studio, it tells me that I should sync to get my changes up to the server. So I'll go to the Sync page in Team Explorer, look at the outgoing commits, and click Push, and that'll actually upload that change to the server. So if I go back, hit Reload on the History page, now you'll see that we made that change and it landed in the actual server repository. Okay? Again, Team Foundation Server and Visual Studio Online are all about combining version control, bug tracking, build and test integration. So I actually have a continuous integration build set up for this project. When I click on the Build tab, it's going to load that. If I click Queued, you'll notice that just a minute ago, when I pushed up to the server, it kicked off a CI build. So hopefully that'll succeed. And so when my buddy was telling me about how, about his problems, about how he was fetching software that simply didn't compile, I suggested that maybe he invest in a continuous integration system. Because this sort of system will show you at a glance immediately that you've broken the build when you do a push. We'll take a look at some ways that we can avoid actually getting it into the server in a minute. Okay? So, I hope that looks very familiar if you're using TFVC. But I want to talk just for a minute about how this actually works. Because this is actually some kind of cool stuff to enable everybody to have a copy of their own repository. So if I start out with my own copy of this repository, let's say I clone the repository down to my machine, and I've just got 3 changes. Commit 1, commit 2, commit 3. And I'm working with one of my coworkers, let's call him Bob. Bob does the same thing. He clones the repository down to his machine. Now he's got those same 3 commits in history. If I make a change, check it into my local repository, I'm going to make change number 4. Bob makes a change number 5. When I'm ready to bring Bob's changes into my repository, when I'm ready to combine our changes together, what I do is I fetch his change somehow. I get his change into my local repository. But that actually hasn't done any sort of combination with our changes. What I need to do then is I need to actually merge change 4 and change 5 to produce a blend of 4 and 5 to get 6. This is actually, exactly how we tend to think about branching and merging is making independent changes and combining them back together. Okay? I told you a little bit of a lie. Commit IDs aren't quite so simple as 1, 2, 3, 4, 5, 6. That's something that exists in TFVC. You have change set 1, then change set 2, then change set 3. The real problem here is that there's no server to tell you who gets change set 4, who gets change set 5. Right? The whole idea is that this is a distributed system where you don't need a server. So it's not quite that simple. What we actually do is we take a cryptographic hash of the contents of each commit. And that's how a commit gets its ID. These end up to be 40-character long hexadecimal strings that are really insane to look at. If you're coming from TFVC, it's sort of maddening to go from, change set 42 to something that's 40 characters long. The nice thing is that we only really need to talk about the first, say, 6 or 7 characters. And in many big projects, you hit change sets into 6 or 7 digits anyway. So it's not really the end of the world. But I mention this for 2 reasons. The first is that you're going to see this throughout the demo. You're going to see, commit AB 4, 5, 6, 7. And I want you to understand where that comes from. But we'll talk about it more in a minute when we talk about applying changes. Okay? So we've seen creating commits, we've seen pushing commits, and that's certainly an important part of any version control system. I would say that the second most important part of any version control system is actually the ability to branch and merge. Okay? Branching, of course, allows for parallel lines of development. It allows me to work on whatever feature I'm working on while my coworker Bob was working on his bug fix. My other coworker Carol is working on her new feature. It's very powerful, and Git's branching support is what kind of sets it apart from a traditional version control system. Branches exist at the repository level in Git. This is different than TFVC, where you have a folder called main, and then you branch it, and you have a folder called feature branch. You have another folder called bug fix. Instead, you have a whole branch at a time with Git. Okay? This allows them to actually be exceptionally lightweight. Because we've sort of seen how these commits kind of fold into each other when people are making independent changes, it turns out that that's the mechanism we use for branching in Git. Okay? Well, let's go back to this little picture of what our history graph might look like, and we just put labels on it. My branch, the one that was up top, I'll just put a label on it, call it mine. That orange-colored branch, we'll call it Bob's. And that's as simple as branching really is in Git. It's just a pointer on the graph. So if you want to create a new branch, you don't need administrative permissions. You don't need to copy a lot of data. It just sets a pointer in the graph. It writes, just a single file to disk, and that's as simple as it is. Okay? When I merge these 2 branches, moving forward, that pointer moves along with me. Okay? And if I were to make another commit, it would just still keep pointing to that location. Let's take a look at what that looks like using it in Visual Studio. If I come back to VS, I'm going to go to Team Explorer, and I'm going to go to the branches page. And if you zoom in, it turns out I've really only got one branch right now. It's in bold. It's called master. That's, if you're used to Subversion, you could think of that as your trunk, or your head, or your main, depending on what version control system you're familiar with. And Git master is the default branch. Okay? So I'm going to create a new branch off of master, and it's as simple as right-clicking, new local branch from, give it a name. I'm going to call my feature branch feature. Click create branch. And now feature is in bold, indicating that it's the checked out branch. I mean, that just took a second. I know this is a small project, but even on a large project, it's instantaneous. It's just updating a pointer in history to where your new branch is. Okay? If I want to make another change to this file, make a change in my feature branch, and I'm going to check it in. I'm going to go to the changes page and check into feature. Okay? Very straightforward. If I want to come back to the branches page, one of the great things about having branches that point to the entire repository is that it's really simple to switch branches. All I have to do is double-click, and my branch changes. Git updates all the files that have changed between those two branches, and it's very efficient, very quick to switch between branches. So if I'm working in one branch, making this new feature, and I get interrupted. Let's say I need to do a quick little bug fix, and I want to do that in this branch over here. Just double-click, and you'll notice as soon as I do that in the editor, those contents change. And now I can make a little bug fix in master, commit that, and those stay completely independent. Okay? Commit that. And so again, I can just bounce back and forth between these two branches on the branches page, and you can see the contents updating. When I'm ready to merge those changes, I can just, on the branches page, right-click, go to the Merge tab, select my feature branch, and now I'm merging all those feature changes into master. Click the Merge button, and it turns out I actually changed the same region of the same file, so I have a conflict. In TFVC, we often cringe when we see conflicts. One of those reasons is that in TFVC, branching is expensive. It does take an administrator. It does require copying a lot of data back and forth. So you tend not to do it very often, and you tend not to merge very often. And so when you do, you have a lot of changes, and you have what at least we kind of refer to as a big bang merge. I'm not sure where that name came from. Certainly, might sound like your head hitting the table every time you have to see it. But you tend to have a lot of conflicts, and it tends to be really frustrating. In Git, branches are easy to make. Merging is easy to do. And so you're encouraged to do it more often. And so you see less of these huge problems. You still have conflicts, but the goal is to have fewer of them. Okay? And when I do have a conflict, I can just click on it right here in Visual Studio. It shows up in Team Explorer. If I double-click, it's going to open up in our three-way merge tool. Same tool that you see in TFVC, but again, hopefully with fewer conflicts. And I can just pick whichever tool, pick whichever change from whichever branch I want to include. Maybe I want them both. And maybe I actually want to do a little editing after the fact because the auto merge didn't quite go right. Maybe I want some white space between them. And when I'm done, I can just click Save, come up to the button up here, Accept Merge, and that resolved the conflict. Okay? If I go back to the Changes page, my merge is in progress. I can see exactly what changes I'm about to commit in my merge. and click commit. Okay? So through this, we've kind of been talking about and visualizing this as some commits that diverge and then come back together, as if that's the way Git models its history. It turns out that that's actually exactly how Git models its history, is as a graph. It's called a directed acyclic graph. I didn't do well in graph theory, so don't ask me too much more than that. But I do know that if I right-click here on a file and view history, I can see this simplified version of history. This is not that graph that we were talking about. This is just a simple line. This is, in Visual Studio, we call this the simplified history view. Something new in Visual Studio 2015 is the detailed history view, and we're really excited to show this off. If I go over here to a branch, on my master branch, view history, and now I can actually see this view of the graph. I can see where, right here, obviously we have some users who are using VS 2013. This is one of the most requested features in VS 2013. This is one of the ways that you really get some real insights into the way your Git repository looks and works. So right here you can see a couple commits down from the top. You can see that history branched. I made a bug fix in master. I made a change in feature, and then I merged those changes together. Yeah, there's a question.
I'm intending to throw your process up. I noticed you haven't spoken about pull and fetch and push yet.
That's true. So the question was really how to share changes with remotes. How do I work on the server? Let me talk a little bit more about that in a minute. I tried to touch on that. Yeah, but yeah, and I kind of glossed over some of the details there. I'll come back to that. Yeah.
When you create branches, can branches be hierarchical? So if you have a branch and a sub-branch, sub-branch?
The question was, can branches be hierarchical? And so not in the way TFVC works. So in TFS version control, you have a main branch, and then you can branch off for a feature crew, and then each of them can branch off into sub-features. And in TFVC, when you do that, you have to roll up your merges. So I have to merge from my lowest point in my branch hierarchy. So let's say I've branched A to B to C. When I want to change back into A, I've got to merge C to B and then B to A. And that's great for some teams, actually. We work like that on many teams at Microsoft. You don't have to do that in Git. In Git, you don't have a hierarchy of branches because branches are just a pointer to this sort of vague graph history. And so you don't have to merge from point to point to point. You can simply take any two branches and merge them. Okay. Yeah.
This comes from a Git experience person. Basically, the philosophy is branch early, branch often, commit early, commit often.
Exactly so. The statement was branch early, branch often, commit early, commit often. And that's exactly right. Because I'm committing locally, I'm not sharing these commits with my coworkers yet. I have more freedom to experiment because I'm not polluting everybody else's source tree if something goes wrong. So I can make a quick fix. I can do some refactoring. I can check that in locally. And then I can say, well, maybe I want to do a little bit more. Maybe I want to experiment here and see how it goes. If it goes well, great. I'll commit that too, and eventually I'll share it with everybody. If it goes poorly, I can undo that last change but keep the others and then share what I want with them.
So, something, I must have missed a step, but you said you don't share the code with your coworkers yet. You did it following up the Git repository. So you have your own copy of the repository. How did Bob get involved?
Right. So the question was, how did Bob get involved? I said I didn't share those changes. So I think this goes back to an earlier question. So let me Let's go back to this master branch, right? So I made this change. I have this feature branch right here. I made a change in feature. I merged it into master, and this was all done locally. So at this point, my coworker isn't involved. So if I go to the server, click on the code tab, click on history, the changes I just made literally are not there, right? I've made all these changes locally. They still exist locally. I can look at the history and see them, but they're not on the server. So I'm in the free to experiment time right now. I can keep making changes. I can undo these changes if I want. I can do whatever I want in my local repository, and nobody else is seeing it. They haven't hit my continuous integration server. Nobody, if they were to go download it, would see this. When I'm ready to share these changes, I'm going to go to the sync page in Visual Studio, and it's going to show me outgoing commits. These are commits that exist only in my repository and don't yet exist on the server. When I'm ready, when I feel confident about their quality, when I'm ready for other people to start working on them, I'm going to click push, and it's going to upload them to the server. Alternately, if somebody had uploaded some changes to the server from their repositories, they'd be up here in the incoming commits section, and I could pull those into my repository, like we saw earlier with what I did with my coworker Bob. So I'm going to click push, and it's going to tell me I have no more outgoing commits because they're all on the server. If I come back over to Visual Studio Online, so on the server, if I hit reload to get the new history, we do see those changes now. We see the merge change. We see the change to the feature branch. If I click on the commit, I can drill down to exactly what changed. And if I navigate through here, we'll actually see that now I have the same contents on the server that I have in my local repository. Yeah, one more question.
Can you concatenate commits on your client using Visual Studio?
So the question is, can I concatenate commits? So I pushed up, if you remember, I had 3 commits in my outgoing commits that I pushed up. The question was, can I concatenate that into maybe a single commit? Sometimes we call that squashing the commits. The answer is, at the moment, no. That's not something that we have in the client yet. But we do have some support for changing the nature of the commits. Okay, I'm sorry. There's going to be plenty of time for questions later. I'm sorry. Let's take a look at what that looks like real quick. So branching and merging, really great, really powerful in Git. One of the other cool Git workflows is a piece of functionality called rebase. Rebase means many things in the Git world. What I want to talk about real quickly is how to keep your history sane, if you will. So we've seen this. We've seen the graph. We've seen how the graph looks, how the graph works. One of the problems with the graph is that if you want to sort of see the insight into the graph, if you want it to impart some understanding of how your changes got made, and I think we do. I want to visualize what happened on each branch, right? I want to see in that graph that we saw earlier that I diverged and then I came back together. The problem is that if you don't pay a lot of attention to how you're making your changes, this can start to look a little hard to understand. You can get lost in the branches that are existing. I'm here in a Git repository. I'm going to use the Git command line client, and I'm going to look at the Git command line client's history because Git itself keeps its history in Git. And I'm going to use it to visualize the graph. Okay? And you can see some of these changes, branching, coming together. And it looks pretty sane right now. But it doesn't take very long before this looks like a 10-lane superhighway that's kind of careening out of control. And it's easy to get lost in what's going on. And the further you go back, the worse it gets. I mean, we can't even read the comments anymore. And it just goes on and on like this. And there's nothing wrong with this, necessarily. If this is the way you want to work, that's fine. If you don't care about what your graph looks like, that's totally fine. Git gives you a lot of flexibility. But if you do care what your graph looks like, this is really frustrating. Because it's hard to tell where the changes came in any particular release. And so instead of merging, you can use a very similar technique called rebasing. And it's got a funny name, I admit. But if we want to take a look at the same sort of graph picture that we've been looking at throughout, with Bob's changes in orange. If I want to bring Bob's changes into my repository and I don't want to merge them because I don't want another lane in that terrible, terrible superhighway, then I can rebase them. And what that does is it plucks those changes off and brings them onto my commit. So now instead of having a merge, having a divergence in history, and then a merge back together, I've actually just got a straight line, which is much easier to follow. And you can combine merging and rebasing to, one of my coworkers calls this graph polishing, to give you a graph that looks very understandable. And so you can follow what changed over time. Okay? One of the things that you notice, before we do the rebase, when we start out, we have some commit IDs. Bob is pointing to commit ID A8C569D. But again, commit IDs, the terrible 40-character long hexadecimal strings, are made up of the contents of the commit and the contents of the commit's metadata. So where they are in the graph actually impacts the ID itself. So when I do this move and I kind of bring these changes up, the commit ID actually changes. So what I'm actually doing is I'm not changing these commits. I can't change the commits that Bob made because that would change their commit IDs, and by definition, those are different. I'm actually recreating new commits with the same contents and putting them in the repository. So this is sort of advanced stuff, to tell you the truth. And there's many other aspects to rebase. One of them is squashing the commits. I could turn Bob's 2 changes into 1 in the graph if I wanted to. We don't actually support that in Visual Studio, but we do support some rebase functionality in Visual Studio 2015. This is actually one of the most asked for pieces of functionality in our Git support, aside from the graph view. So, if I come back to Visual Studio, I can go through the same sort of workflow I was in before, where I was merging branches. This time I can create a new local branch. Let's call it Feature 2. If I go to this file in Solution Explorer, let's make some more changes here. Okay. I'm going to go ahead and check this in. And what the heck, let's make another change. Sadly, one of the problems in Git is because your commit IDs are tied to the metadata, your history is immutable. When you make a typo in your commit message, it's there for life. If I go back to my branches, let's switch over to the master branch and make a change there. and check that in. And now instead of merging these changes, because if I were to merge them, I would have a, again, a split in history in the graph and then coming back together. I actually want to bring these changes together in a straight line. So I want to put them right on top of master instead. There you go. It's done. If you've used rebase from the command line, this is a slow process. This takes time. And it's kind of confusing, to tell you the truth. Part of the nature of Git, it was written by a guy named Linus Torvalds. If that name sounds familiar, he wrote the Linux operating system. It turns out Git was written to build the Linux operating system and run inside the Linux operating system. It works really well in Linux, less so in Windows. It's kind of slow. And rebase is one of the slowest commands in particular. Rebasing just 2 commits could take 15 to 20 seconds. There's nothing innately slow about the process. It's just that the tool is not designed to work well on Windows. Ours is. In Visual Studio, rebasing 2 commits, it happened before I could even, say, hey, look how fast this is going to be. It just happened. And if I look at the history now, again, now these 2 commits are in a straight line instead of a merge. Okay? I know that doesn't seem like a lot to get excited about, but again, this was one of the most asked for features because people were starting to get, and in fact, at Microsoft, some of our Git repositories, we have 25, 50, 75 people working in them. We'd get those same sort of multi-lane superhighway effects that are really hard to understand. Yeah?
What if you get the merge conflict?
If you get a merge conflict when you rebase, you get the same kind of cool, interactive, conflict resolution experience that we have in a merge. So if I change this one line right here in master, and go back to, let's say, feature, and check that in, and if I want to rebase, now I got a merge conflict. I can click the conflict resolution, and I get a nice, again, 3-way merge experience, just like I did with merge. So we're trying to make rebase a lot simpler than what you see in the command line, a lot faster than what you see on the command line, and still with all the same sort of rich conflict resolution and understanding that you would get if you had a merge. So I can just resolve that right here. Go back and continue the rebase, finish it up. Okay, yeah?
Have you made available for some of us command line junkies, jockeys, if you want to get it, the Windows version of it, or do we just still have to use the official Git version of it?
Yeah. So the question was, what about the command line people? So I said that the command line experience wasn't really geared towards Windows users. The command line experience is, there's a tool called Git for Windows. It's an excellent tool that took the Linux version, took all the Unix-y tools in Git, and made them work on Windows. This was a heroic effort, Herculean task. These guys are mad geniuses to be able to make this work. But again, not everything is really one-to-one when you move from Unix to Windows, and so it's a little slow in places. It's not their fault, it's just a disparity. The question was, have we made anything else available? And the answer is no. So it turns out that Visual Studio doesn't call the Git command line client. It calls a sort of re-implementation of Git, which is a pluggable, linkable library. It's parts of the Git command line and new parts. It's an open source package. We work on it with a couple other people like GitHub, a handful of other people that are independent. And this is what powers all of our UI tools. It's what powers Visual Studio. It powers GitHub for Mac, GitHub for Windows. It's great, but it's not a command line app. So if you are a command line user, Git for Windows is still the way to go. We are, however, starting to invest more in that area. We'd like to see the command line tools improve because a lot of us are command line junkies too. Okay. Sorry, there'll be plenty more time for questions at the end. I'll stick around as long as you want. I'm happy to talk about version control. So we've talked a lot about making changes to your local repository and just blindly pushing them up. What we haven't talked about is code review. Code review is a really important part of any development process. It's what keeps your quality high. No matter how good a programmer you are, it's so easy to overlook a minor change that could cascade out of control. Maybe you're changing an area that you're not as deeply familiar with. Maybe maybe you had a bad day. Maybe you just missed something. It happens to all of us. Pull requests are a hugely important part of the development process. And so doing code reviews in Git is often done with what we call pull requests. In a pull request, what I do is I make some changes. I push a private feature branch up to the server, and then I ask the server to do the merge once my coworkers have signed off on it. Okay? This is a really neat workflow. It sounds a little strange at first, but what we do is, if let's say Bob makes some changes, he pushes that branch up, Bob's branch, up to the server. He doesn't do the merge himself. He doesn't merge his changes into master, into the main line, and push them up for everybody to see. He pushes his branch up and lets the server do the merge after everybody's signed off. That sounds a little bit wacky, I think. Once you see it, I hope it makes a little bit more sense. Okay? So right now I have some changes outgoing to master. Let me go ahead and just first switch to my master branch. Sorry. And then go back to the sync page and push. That way, the state in my local repository is now identical to the state on the server. If I go click over here, look at history, I'm at this change right here on the server and on my local machine. Okay? So I don't have any changes yet. I want to create a new feature branch that one of my coworkers can review. So I'm going to create a new local branch. I'm going to call it Feature 3. And it went ahead and checked that out. So first of all, I'm going to remove that because that doesn't compile. I'm just going to add a comment. Okay. Make sure to get some eyes on that. I'm going to check it in, again, just locally. And again, this is just checked in locally. Now when I want to upload these changes to the server, I'm going to push them. And since I'm creating a new branch on the server doesn't have my feature branch. I'm going to do what's called publishing it. The workflow changes just a little bit. If we zoom in, push is grayed out, which is how I would normally get my changes into a branch. And now publish exists. That's how I create that new branch. Okay? I'm going to click Publish. And now if I go back over to the server, I click Branches. And now I see that I've got this Feature 3 branch right here. Okay? I can click on it. It shows me that one change that I've made there. That's the change that I just made locally. When I'm ready for this branch, and I can keep pushing into this branch as long as I want. When I'm ready for this branch to actually make it into master, when I'm ready for this branch to land, if you will, for the changes to get integrated and available to everybody, I'm going to go through the code review process. And that's up here under the code tab. This is something that doesn't actually exist in TFVC. This is only in Git right now. And that's the pull requests tab. So I'm going to click that. Click New Pull Request. And select the branch that I want to merge in. Once I do that, I get a chance to look over the changes that I'm requesting be merged. I can name reviewers right now if I want. If I scroll up here, I can add reviewers. And this could be anybody on my team. I'm just going to add myself as a reviewer. It turns out I don't have a lot of team members on this project. It's kind of a sad life I lead. Oh, hey, look, I do have another reviewer. This is my buddy Martin. He's in a very different time zone, and he might get woken up with an email right now. So, sorry, Martin. But I'm going to go ahead and create that pull request. And what that does is it notified me, it notified Martin. I hope his wife's not mad. And it's going to show that reviewers tab down there. Now, as a reviewer, I can come over here and look at the code discussion. I can look at comments that other people have made about the code. I can leave comments for the author myself. Okay? It's really easy. It's really straightforward. If I click on the code tab, I actually get to drill down on the diff. I actually get to see the lines that were changed, and I can leave a comment on a particular line of code. I can say, hey, yeah, this actually looks great. And now that information is stored right on that line of code. So you can, if you're arguing over a variable name or spaces versus tabs, you can do it right there in the code. You'd be surprised how many arguments I have about this every day. And once the reviewers sign off, they can come in here, they can select their response to the topic. They can say, hey, I approve that change, or no, I didn't. Up here at the top, you see the status of the code review. We've got a green checkbox that says reviewers approved, and right above that, we've got a checkbox that says no merge conflicts. What we actually did when we opened the pull request was we asked the server to investigate the merge. It computed the merge. It didn't finish the merge. It didn't actually put my changes into master. But it did make sure that there were no conflicts. If there were conflicts, this would have turned red. The code review would have been, the pull request would have been rejected immediately because it didn't merge at all. It's impossible to make that happen. Some of the cool stuff that you can do coming soon in Visual Studio Online is the ability to actually do a build right here and get build results. So if your build succeeds, then you get another green checkbox saying that the build succeeded. If the build fails, you have the opportunity to, as an administrator, say, I don't want any failed builds going into my source tree. So it can reject the pull request that way. Okay. When I'm ready to finish the pull request, when everybody's signed off, everybody's happy with this, I can click Complete Pull Request, and that's actually going to finish the merge. It's going to put my changes into master, and it tells me where, commit 615E39. And now that's in master. If I actually go back to the branches tab, we can see that. Sorry, if I go to the Code Explorer, yeah, I can see that. If I click history, we can see that that change actually landed in master this time. Okay. That's pull requests. That's sort of the code review workflow that's very popular in Git. Yeah. Any questions? Yeah.
Possible to add the manual activity steps in the review list?
The question was whether it's possible to add manual activity steps. I actually don't think so. That's actually really good feedback. I'm going to take it to the team. We're putting a lot of effort into pull requests right now, and so especially in Visual Studio Online, you're going to see some new changes coming soon. It's the great thing about Visual Studio Online. on the Visual Studio team, we work in an agile process. We have 3-week sprints. At the end of every 3 weeks, we publish to Visual Studio Online. So you'll start seeing new features light up in Visual Studio Online as soon as we're done with them. Unlike Team Foundation Server, which is an on-premises product, you get TFS 2013, you get a couple of updates roughly every couple of months, and then you get TFS 2015, and you'll get a couple of updates to that. With Visual Studio Online, you get new features as soon as they're available. So we're going to see some really cool stuff coming into pull requests soon. Yeah?
You mentioned that Git was more optimized for small code bases. Where does that break over the point where Git starts to be slow for large code bases?
That's a great question. The question was, when does Git start getting slow for large code bases? Because I said it's really optimized for small code bases. What is the metric by which it starts getting slow? It turns out that there's actually a couple of different directions that you can take. First of all, the number of files that are actually in your repository. The second one is the length of history. And those two actually have, sort of different dynamics. Because when you do a clone, you get all that history. And so if you've got, let me just pick a number, 50 years worth of history on a large project, it's going to be exceptionally slow to download that first time. But after that, it may not be slow to use. Maybe you've got a project that's, 4 files. But it just turns out that they've had a lot of changes over time. So that way, and there are ways to mitigate that. Maybe you don't need to download the entirety of history. So it's hard to actually put a concrete number on this. You'll know when you get there. That's a terrible answer, I know. It makes planning hard if you want to do a migration. I'll talk a little bit more about that in a second, though. Yeah.
A couple of questions.
Oh, sorry.
Referencing the root repository,
Yes.
how do you create a new project root repository?
That's a great question. It was, how do you get started with a repository? We went to a repository online. We cloned it. We never created a new one. It's super straightforward. It just takes a second. If I'm in Team Explorer, I'm going to go to the Connect page, and I'm going to click here at Local Repositories. This is where we cloned. I can click New and create a new repository. And I just give it a path, just a path on disk. There's no complicated setup. Again, I don't have to be an administrator.
Right, something on the server to do the shared repository.
Okay. So that's how I create a local repository. How do I get a repository on the server? If I go over to Visual Studio Online, go to the Code tab, I can click this repositories button. And so these are the repositories that I have associated with my team project. Right now I've got one that we've been working in. I've got another one called Test. Below that, I've got this button that's Manage Repositories. Okay. And I can just create a new repository. Okay. And if I come back here, hit Reload, now that repositories dropdown has new repo. And when I navigate to it, there's nothing there, right? I just created it. It has no history. It has no data in it. It gives me some instructions for how to upload an existing repository that I have locally, or how to simply start using this repository on the server locally, at which point I'll have a local repo that has no changes. Okay? So super straightforward, doesn't require any special permissions or administrator type stuff. Yeah?
One follow-up question is, now, creating a repository on, say, a Linux server
Yes.
that using SSH, the only protocol to get it, but you don't have shared drive space or anything else.
Okay.
So is that something you can do, or so how?
So the question was, what about interoperability with Unix? Like I said, Git is sort of this tool that everybody's building tools on top of, including us. And a lot of people, like I said, Git comes from a literally a Linux background, and so it's very popular on Unix. One of the other things that's popular on Unix is the SSH protocol. What I've been showing here has been using HTTP, which is a perfectly reasonable way to talk from a Git client to a Git server. But another way is SSH, and it's quite popular in the Unix world. It is not something that we support in Visual Studio Online at this time, or Visual Studio. There are a plurality of reasons, but it's something that we are interested in seeing. So, yeah.
Now, I noticed there's a search thing there for like commit ID, which is baffling and impossible to figure out.
Yes.
Is there any sort of search mechanism for actually searching through code? So let's say you have like 30 repositories, things like Bitbucket, GitHub, I could go on and on and on and
Sure.
on. Have the ability to search through your repository or multiple repositories and show you what you're looking for.
Yes, they do.
So is there a way we can do that here?
That's a great question.
Is there any plan to include it if you can?
So this is one of those questions where I don't know what we've announced at Build and Ignite. And so I certainly couldn't promise features that are coming or give you a date when they might come.
Describe how it would work in the query.
You know, I could see a hypothetical search box there that didn't just search the commit ID, but also searched textually for things. Thank you. There was a kind audience member who just bailed me out of this never-ending spiral I was going down. There was a session on this earlier today. We do have code search. I actually am a little bit surprised that it isn't on my account. But yeah. It turns out that if I type something reasonable to search for in there, it tells me it's not a real commit ID. This box only lets me search for commit IDs. You will apparently be seeing very soon a search that will actually search through the contents of a repository somewhat intelligently. Yeah, in the blue shirt.
What is the traffic flow like? Does it act like a BitTorrent and all the clients talk to each other, or is it a central repository?
Oh, that's a really cool question. So it was, how does the network traffic work? We've talked about distributed version control and how all the clients are kind of independent. You don't need a central server. Does that imply that that they somehow interact in a distributed manner like some distributed file transfer protocol, like BitTorrent or something like that? Sorry, I choked on the name. I almost said, yeah, anyway. No, actually, the idea is not necessarily that clients talk to each other, although you could explicitly talk to one of your coworkers. But the common situation is that you do have a central server that you use. You push your changes to a central server. At that point, somebody pulls the changes from that central server, and that's actually how you share the commits. That means you still have one source of truth, so that all of your changes, all of your builds are coming out of that central server. That's really kind of the best practice. Yeah?
I noticed that you have a local copy of Visual Studio installed, and that's what you've been using to do a lot of your manipulation. Is that required, or can I do that entirely from Visual Studio Online?
So the question was, do I need a copy of Visual Studio installed? What can I do in Visual Studio Online? You can make changes to a Git repository just in Visual Studio Online. If I navigate, I'm going to keep picking on this same file that I've been using the whole time and just muddying up with my comments. If I click on it, it opens up the actual file's contents. There's a little button here called Edit. And that'll open it up in the Monaco editor that I was talking about earlier. And so I've got all this cool syntax highlighting while I'm editing the file. And so I can change it right in the web. And instead of hitting the Save button, I click this little Save icon up in the corner. And that actually creates a new commit with the changes that I've made. I can update the commit message right here. Click Save. And now if I look at the history, that's included. So now anybody who is using Visual Studio, when they download these changes, they're going to have that change I made in the web. Similarly, I can, I could make changes in VI and use the Git command line client to check these changes in, and then push them that way. I could use GitHub for Mac, GitHub for Windows. I could use any of the tools that talk to a Git repository to make these changes. I'm sorry, so the lights are awfully bright. I know that there were some questions in the back row and I couldn't see you. I'm going to stick around, but just to wrap up, since we're running out of time, I know I'm the only person standing between you and the beer and Fallout Boy, so I'll try to make it kind of brief. If you're thinking about moving to Git, I think it's important to remember that Git is different. I think we've seen a lot of the ways that Git is different. We've seen rebase, we've seen pull requests. These are different than what you see in TFVC. But I think we've also hopefully seen that it's very much the same in a lot of ways. It's good to know that it is different, though, and maybe you need to spend a little bit of time working with your team to make sure that they understand how to make their changes. One thing you can do if you're coming from TFVC or SVN or actually many tools is you can use a tool to migrate history from one into Git. These work mostly pretty okay, kind of. I don't want to tell you not to use them, but it turns out that Git and TFS are sufficiently different that it makes this sort of a migration kind of wacky. Because TFVC has branches, we call it branches in path space, right? You have this folder called main, you branch it, you get another folder called feature. It turns out that there's actually nothing stopping you from checking into both branches in a single change set. That can't possibly happen in Git, right? The history model just prevents it. And so it's not really a one-to-one mapping. It's a little bit fuzzy. And so it's worth trying and seeing what the results are like in your repository. But it's also worth keeping in mind that you may not really need to migrate all your history. You're never going to be able to turn off that server, no matter how well that history migration goes. You're going to want that history, forever. And so, we've had occasions at Microsoft, and I've certainly seen other people do it, where you just grab the latest version and check it in, keep the old server alive in case you ever need to look at that history, and go. Okay? That's a perfectly reasonable approach. So is GitTF or GitSVN to migrate the history. But if you do use something like GitTF or GitSVN, really move to Git. These tools can also operate as a bridge so that you have changes in SVN, you have changes in Git, and it can kind of go between them. I find this maddening. Some people like it. The last time I had somebody tell me that this was a really great idea was about 2 years ago, and I think 3 or 4 months ago, she then told me, no, it's terrible. I think the more you do this and the more you run into trouble, the less you like it. Okay? The other thing you want to do is you probably want to break up your repositories before you move them. Like the question over here, how do I know what will fit? Instead of trying to break repositories up just to get them smaller, I think it's really useful to break repositories up into logical chunks, right? In TFVC, I'm going to have several projects in the same TFVC repository. In Git, I would break those up into several independent Git repositories. So kind of with an affinity for one project to one repository. Okay? If you're interested in Visual Studio Online, it's free for small teams. It's included in MSDN. It's a really cool way to use application lifecycle management. And I hadn't seen this slide before. So yeah, there's a free upgrade to Visual Studio Enterprise with MSDN. There's some interesting information. You can follow those links. Thanks for sticking around. I know that, again, this is right before the party. And again, version control, not really the sexiest of topics. But please do rate the session anyway. Thank you. And I'll stick around to answer questions. And if you want Git loves Visual Studio stickers, I've got a bunch of those too.